Hey scholars, welcome back. Today we are covering the law of sines. It's not a big topic, but it's an important topic in pre-calculus, trigonometry, maybe even algebra 2. You'll see it. Okay, so keep watching, okay? I have nothing else to say. Okay, y'all, so what's our motivation here? Let's be astronomers for a second. So we have 3 stars here. We're trying to figure out how far away this third star is. We don't know where it is. We don't know how far away it is, but we're trying to find that out. So we know the distance between two known stars. We know that distance, which is 4.7 light years away. Then we're trying to find this third distance, right? So we're trying to find those 2 unknown distances. We can see the star, we can see it that far away, so we can measure out what the angle is between the 2 other stars. We know that this angle on the right is going to be 70 degrees and the angle on the left is going to be 40 degrees. Okay, so now how do we find the distances? How do we find it? That's our motivation here. So we have this triangle. The A's are corresponding sides and angles. Okay, so they're opposite of each other. So that's something you should know. Okay, so this is a law. It's been proven. I'm not here to tell you how to prove it, but I'm telling you that it exists and that you should know about it, okay? So let's solve this problem. So my little Apple Pencil was acting out, so I have to refilm this. Let's solve this problem. So this is what we're given. We know this law that we're going to use today, and we're going to use it because we have 2 known degrees, and 1 side length. Okay, so first things first, we're going to identify which is which, okay? Let's just call this 4.7a, and knowing that's little a, the opposite angle is going to be big A, like that. And then arbitrarily, we have this 70 as B, so little b is across, and then we have that 40 as C. Okay, so we named these things. Okay, now we have little a, big B, big C. Now we need to find big A, little b, little c. To find big A, all we got to do is subtract from 180, and you already probably know this, okay? You already probably know this. So 180 minus 70 minus 40 is going to be 70. Now, in order to find the side lengths, which is what we need to find, we're going to use the law of sines. So let's do it. And I'm going to have a calculator next to me because I need one. I can't do sine of 40 in my head. That's not me. Maybe it's you, but not me. Let's first try to find B, little b, which is this. We know big A and small a, so we can use this part of that law of sines. So that small a, 4.7 over the sine of the big A, which is sine of 70. And that is going to be equal to little b, which is unknown, so I'm just going to keep it that way. And then we have sine of, what is the angle across little b? 70. Wow, would you look at that? The sine of 70 is going to cancel out, and this is an easy problem. So b is just going to be 4.7. If you don't believe me, try this on your own and you'll get to the same conclusion. 4.7. It is the same amount of light years away. We have to find c, little c. Let's do the same thing, although you're going to need a calculator. So we get c equal to sine of 40 times 4.7 divided by sine of 70. And what do you get? I don't know. If I did my calculations correctly, I get 3.21 light years. Good job, friends. One thing to note is that sometimes you might see sine A over A equals sine B over B. If you think about it, it's essentially the same thing. Proportions you can flip around and you'll get essentially the same thing. Like I said, if you don't believe me, then do it yourself and see what happens. Okay. So let's finish off with a harder problem, okay? All right, so find the area of the following triangle, rounding to the nearest 10. Okay, so what is the area of a triangle? It's 1/2 times the base times the height. Okay, so we need the height and we need the base. So the base is just going to be this one. This is the law of sines. So we're gonna do this, let's call this A. So A over sine of 84 equals, we have to find this angle, which is 180 minus 84 minus 37. That is going to be 96 minus 37, which is going to be 59. I don't know why you're so loud. Okay, so then we can figure that out. So sine of 59 over on the bottom, so it's gonna be 5 over sine 59. Okay, so A is gonna be equal to 5 times sine 84 over sine 59. Okay, A is going to be equal to 5.75 for this side. Okay, so the base is 5.75. Now we need to find the height. So we can't assume that the angle, if we to have this in half, we can't assume that that's going to be 84 divided by 2. We can't assume that. Why? Because these are different angles. So that's going to be completely wrong. So we have to find the angle a different way. So we have 37 here. This is a right angle. So this angle is going to be 180 minus 37 minus 90, which is going to be 53. Okay, so that's the angle. We know one side here, 5. So now we're going to have to figure out this x here. Or you know what? Let's call it height. Let's call it height. Okay, so height over, stop moving. Height over sine 37 is going to be equal to sine of 90 and 5. So we know that sine of 90 is going to just be 1. So 5 times sine of 37 is going to be about 3. It's not exactly 3, but it's about 3, okay? So this height is going to be 3. Okay, let's figure out the area. Area is 1/2 times base times height. That is going to be 1/2 times 5.75 times 3. And we don't have to label it because there's no given units. So that's all I got for you. That's the area of that triangle. Of course, I forgot to follow my own instructions, but we have to round to the nearest tenth. So my actual answer is going to be 8.6. Okay? Got it. Okay. Thanks for watching. We love the law of sines, and we love you. Bye.